Hi everyone! In this video we're going to be reviewing a paper by Huth and colleagues done in October 2016 at the University of California. This study is conducted because of the interest that's been developed in decoding stimuli or mental states from brain activity using fMRI. Decoding is essentially trying to find the stimulus that is most likely to have evoked the bold responses observed in fMRI. Prior studies in this field have found that way more information than we thought was possible can be recovered from bold fMRI. One recent study, also done by these researchers, showed that it is possible to decode the appearance of rapidly changing natural movies using fMRI. fMRI had previously been shown to only be suitable for studying slow phenomena, so the fact that it's now being used for faster moving movies is relatively new in the field of fMRI. This study extends prior research by decoding which categories of objects and actions are present in natural movies, like Planet Earth kinds of movies. The hypothesis in this study was to show that it is possible to accurately decode the presence or absence of many object and action categories in natural movies from bold signals being measured using fMRI. These categories include general categories such as animal or structure, specific categories such as canine or wall, as well as actions such as talk or run. There are two main ways to do decoding, which again is figuring out which stimuli lead to the bold response. The two ways are through Bayesian decoding and through direct decoding. Both methods have their limitations, so for this study they chose a direct decoding approach called the hierarchical logistic regression model. The hierarchical logistic regression model, or the HLR as we'll refer to it as from here on out, decodes the conditional probability that each category is present given that its parent categories in the hierarchy are also present. For example, the HLR model would be determining the probability that the category car is present given the probability of a motor vehicle and station wagon being present.
I'm going to explain the methods that they used to conduct this experiment. The experiment consisted of 7 subjects and about 2 hours of footage from natural movies. Think Planet Earth. A program called WordNet was used to label salient objects and actions in each 1-second segment of the movies. WordNet is essentially a lexical database for the English language. There were 2 stages to the experiment, the model estimation and the model validation phase. In the model estimation, subjects were shown the 2 hours of film footage while their bold responses were recorded using a 3T Siemens Trio scanner using a 32-channel volume coil. In the model validation stage, the same 7 subjects are shown 9 minutes of natural movie material in 10 different sessions. None of the videos overlap between the estimation and validation stages. The responses were averaged to reduce noise. Estimated models from the estimation stage were then used to decode which categories were present in the movies. This method essentially tells us the probability that a category is present given that its superior categories in the hierarchy are also present. One issue with this method of the HLR is that the assigned labels might be inaccurate or noisy. The researchers accounted for this by using a re-estimation technique that found the maximum label error probability is 0.0086, less than 1%, indicating that the model estimation dataset is accurate. The analysis technique used in the study is called the Receiver Operating Character Analysis, or ROC. It is essentially used to assess how well the HLR model is doing at decoding accuracy in each category. They find the number of false positive detections and true positive detections and plot them against each other. Now we're going to talk about the results of this study. This figure here shows the HLR model decoding for a few different categories: talk, animal, vehicle, and thing. Along the left is the probability that a specific category is present in the movie. The blue lines show the probability, and the gray refers to the time points where it was actually present in the movie. The decoded probabilities for talk and animal are high when the categories are present, and lower at other times. Decoded probability for vehicle and thing are less accurate than talk and animal, but that is consistent with the fact that the decoding model assigned low confidence to those predictions. The ROC analysis is on the right. This is the graph that we mentioned earlier that summarizes the decoding accuracy for each category. The ROC curve shows us that both talk and animal are decoded accurately, while vehicle and thing are not decoded so particularly well. Overall, these results show that it is possible to accurately decode the presence or absence of many object and action categories in natural movies from bold signals measured using fMRI, which aligned with their original hypothesis. Decoding accuracy, however, was better for some categories than others. Decoding accuracy tended to be better for scenes that contained relatively fewer categories than for scenes that contain relatively more categories. So the amount of category-related information in bold signals in each time point is limited. Some limitations of this study is the HLR model itself. It is a good model in some ways because it provides a mean to decode information at many different levels of detail at the same time, which is important for decoding natural stimuli especially. Its drawbacks lie in the way that the model assumes that all levels of a category elicit similar brain responses. This problem stems from WordNet, which is not guaranteed to represent brain activity. Some types of relationships are not reflected by WordNet. For example, relationships that are technically correct, but where the object fails to share many features with the general category. An example of this is the relationship between plant and organism, which was not reflected in brain activity, probably because plant is the only inanimate category for organism. Future studies could overcome this limitation by either changing or removing these poorly represented relationships altogether. They could also replace WordNet with a hierarchy learned entirely from brain data, which has been found to be effective in other studies.
One alternative to the HLR approach could be to decode only basic level categories. Doing so would definitely simplify some of the aspects of the modeling, since it would remove the need to account for relationships between categories. These basic level categories might also be better represented in the cortex than hierarchical categories, although it's important to note that the overall power of this basic decoder would be less than it is for the HLR decoder. One other option as an alternative to the HLR model would be to not represent categories as binary variables, but instead as vectors of features, topic probabilities, or co-occurrence values from a larger collection of text. This could improve generalizability and remove the assumption in the HLR model that each category is independent of every other category and its parent categories. For example, although road and car are distantly related in the WordNet classifications, they obviously coexist pretty strongly in our environment. Decoding performance could also be improved by the existence of a model that takes all of these statistical relationships into account and combining information from other categories that WordNet does not directly relate. This field of reading brain responses has generated a lot of interest, both in academia and in the general public. These particular results are important because it tells us what needs to change going forward with research in this area. The current methods used in this type of research, including the HLR model used in this paper, assume connection between variables that are not always interdependent. They also assume that stimuli are independent from time point to time point, which also isn't the case. Removing these assumptions, or at least relaxing them, would likely improve the performance of brain decoders, thus giving us an even greater insight into the stimuli that evoke bold responses.